Hello everyone. Today I'm going to explain to you how the Sn2 reaction works in chemistry. This is the very first reaction that most people will learn in a basic organic chemistry 1 class and will carry over into organic chemistry 2 as well, as it is a very common reaction that takes place in many reactions. So, firstly, the best kind of displacement that we can take place in is a primary halide, such as this bromide here attached to a methyl, ethyl, propyl, butyl group, otherwise known as butyl bromide. So what we can do is we can simply add something like sodium hydroxide, which is a base. As we can see, if we take away this sodium ion here, this is a positive charge, as well as the hydroxide is a negative charge. Therefore, as known by being a halide, the bromide will then displace with the sodium in order to create sodium bromide, and the hydroxide group will simply come in place and take place of the bromide. So in stepwise reaction, we can look at the site of the bromide and think about the hydroxide in solution as being displaced from the sodium ion. So when that happens, what happens is that this hydroxide is no longer bound to sodium and it is very reactive. Therefore, it wants to seek a center carbon that has a good leaving group, such as the bromide. In an actual reaction, you would see sodium bromide fall out of solution depending on your solvent system. And in this kind of reaction, we want to avoid protic solvents because protic solvents, such as water, will stabilize the hydroxide ion and will reduce our chance for this to react. So what we would want is a polar aprotic solvent. Commonly in lab, a polar aprotic solvent that would be used would be something like dichloromethane. What is the structure of dichloromethane and what makes it a polar aprotic solvent? So, dichloromethane is a carbon. Dichloromethane is a carbon bound to 2 hydrogens and 2 chlorines. So it'd look like this. With our center carbon fully happy, we can see that it is polar because these chlorines are inherently polar, because if you look at something such as sodium chloride or table salt, that is a polar separable molecule that can dissolve easily into water, as well as it is aprotic because this carbon is entirely happy with what's all around it. So that means that it will not donate or receive any hydrogens to its center. I'll go further to discuss the difference between polar aprotic solvents and other forms of solvents in other series, but let me go ahead and show you the mechanism, deeper understanding than just the simple backside attack here shown. So if we're to look over at an Sn2 reaction, we should know that the Sn2 always performs what is called a backside attack. The reason it's called a backside attack is because the formal structure of this is to have this carbon bound with the bromide. And of course, in this simplistic understanding, there's hydrogens all around, as we discussed in the first video. So we're taking a screenshot of this section here. And what happens is that the electrons are seeking a center. Why are they seeking the center? Because this is the nucleophile. And in this case, the carbon is acting as an electrophile, as it wants the best, most stable structure bound to it. So once the hydroxide does its backside attack to the carbon, the bromide can happily leave. So what happens is, in the stereochemical picture, now this hydroxide will be on this side, carbon stays here, and then what happens is that now we have a hydrogen here, and the hydrogen moves to the other side. If we were to look at something with a stereogenic center that has different forms of molecules bound to the carbon, this would undergo a rearrangement in the situation, and we should always look for something that is a very good leaving group in order for us to go forward with an Sn2 reaction, such as a big halide like bromide, Or iodide is a very good one as well, because they're very stable because of the amount of electrons that are around the nucleus. If we looked at something like fluorine, there's not as many electrons surrounding the nucleus of fluorine. One final thing to remember on here is that the hydroxide is the most important part as being a very good nucleophile, because this is the rate determining step. Thanks for watching my video, guys. If you like it, please like the video, comment, and subscribe. And join me more for future lessons on chemistry, organic chemistry, and other forms of sciences. Thank you.